A dash is minus 2, 3, 1, 2 and a matrix B as negative 1, 0, 1, 2, then find A plus 2B dash, transpose of A plus 2B. Now here the trick is that you are given matrix A dash and we want to first of all work out A. So A will be A dash dash. That is, what is A dash already given to you? A dash is given to you as negative 2, 3, 1, 2. So take the transpose of it. The first row negative 2, 3 should be written in the first column and the second row 1, 2 in the second column. So that way we get matrix A as negative 2, 1 and 3, 2. Now already you are given a matrix B and you want A plus 2B transpose. So let us work out directly 2B. So what is 2B? Multiply each element of matrix B by 2. You get negative 2, 0, 2, 4. So now you know A, you know 2B. Add the 2 and both the matrices are of the order 2 by 2. So yes, we can add them. So what is the value of A plus 2B? Add the two matrices, corresponding element, negative 2 and negative 2, you get negative 4. 1 plus 0 is 0. 3 plus 2 is 5. 2 plus 4 is 6. So once you get A plus 2B, then there should be no problem in getting A plus 2B dash. It is simply a matter of taking its transpose. So elements of the first row, negative 4, 0 in the first column and that of the second row, 5, 6 in the second column. So your required matrix, the transpose of A plus 2B is minus 4, 5, 0. Just wait. Here. What about A plus 2B? This is A. Please make a correction. When you are adding A plus 2B, this is 1 plus 0. This is 1. So make a correction here. This element is 1. So when you take the transpose, it will be negative 4, 1 here. So now the required matrix A plus 2B transpose is negative 4, 5 and 1, 6. A matrix of order 2 by 2. Now in the fifth sum, for the matrix A and B, verify A, B transpose is B transpose into A transpose. We'll work out AB, take its transpose and then work out A dash and B dash and multiply them in the order of B dash and A dash and the two should be same. So let us first of all work out the matrix AB. What is matrix A? 1, negative 4, 3. What is the order? 3 by 1. Multiplied by B, that is negative 1, 2, 1. What is order? It is 1 by 3. So first of all, let us see, can we multiply the two matrices? The one number of columns in the first is same as the number of rows in the second. So yes, we can multiply. And what will be the order of the required resultant matrix, the product AB? It will be 3 by 3. Let us multiply, we multiply row to column. So you get 1 minus 1 minus 1. Then 1, 2 will be 2 and 1, 1 will be 1. So the elements of the first row will be negative 1, 2, 1. Similarly, that of the second row will be negative 4 into negative 1 will make it 4 and negative 8 and negative 4. And that of the third row will be obtained by multiplying by 3 to the elements of the row in the second, that is matrix B. So you get negative 3, 6, 3. So that is AB. And once you get AB, we can work out its transpose. So what is AB transpose? Write the elements of the first row of AB in first column. You get negative 1, 2, 1 in the first column and that of the second row 4, negative 8, negative 4 in the second column and that of the third row, that is negative 3, 6, 3 in the third column. Call it 1. So we have worked out the left hand side, that is AB dash. And now what is the right hand side? Right hand side is B dash into A dash. Now can I directly write B dash? B is given to you as negative 1, 2, 1. A matrix of 1 row and 3 column. So to find B dash, what do? that take the elements of first row in the first column, that is negative 1, 2, 1. And that is your matrix A dash, or matrix B dash. And what is the order of it? Its order is 3 by 1. And similarly you get A dash. Now A dash, the order is 3 by 1. The order of A is 3 by 1, so that of A dash will be 1 by 3. And the elements in the first column of A are 1, negative 4, 3. So this 1, negative 4, 3 will go to first row. And obviously the order of A dash is 1 by 3. So now we have first of all worked out B dash and A dash, and now let's take the product. Now first of all see, can we take the product? The order of matrix B dash is 3 by 1 and that of A dash is 1 by 3. Yes, this 1 and 1, the number of columns in the first is same as the number of rows in the second, so we can take the product. And the matrix obtained by taking the product B dash A dash, the order will be 3 by 3. So take the product. Multiplying the elements of row with the column, you get negative 1 into 1 as 1. Then continue multiplying with negative 1. So you get 4 and you get negative 3. So the elements of the first row of B dash A dash are 1. B dash A dash is negative 1 into 1 will be negative 1. Make a correction. So it is negative 1 and negative 1 multiplied by negative 4 of course is 4. So negative 1, 4, negative 3. Then multiplying with the elements of second row, that is by 2, you get 2, negative 8, 2, negative 8, 6. And multiplying by 1, you get 1, negative 4 and 3. Call it second. So now we have worked out A, B dash as well as B dash into A dash. And if you compare the two, you find that they are same. So from 1 and 2, we can conclude that AB dash is same as B dash A dash. Now in the second part, again you are given two matrices A and B, and you have to verify that AB dash is same as B dash A dash. So by proceeding exactly like in the first part, you work out the product of two matrices A and B, take its transpose, and then take the product of B dash and A dash, and you will get that yes, it is same. So you can verify as question 5, first part, try it yourself. And now I shift to the next sum, that is sixth sum. You are given a matrix A, cos alpha, sin alpha, minus sin alpha, cos alpha, and we have to verify that the product A dash into A is identity matrix. So let us first of all work out A dash. The given matrix A is of order 2 by 2, so its transpose will also be of the order 2 by 2. Write the elements of first row, cos alpha, sin alpha in the first column, and minus sin alpha, cos alpha in the second column. And now let's multiply A dash into A. So A dash into A is equal to A dash we worked out as cos alpha minus sin alpha, cos alpha multiplied by A. And what is the value of A? The matrix A is given to be, you are given matrix A as cos alpha, sin alpha, minus sin alpha, cos alpha. So let us multiply the two matrices, and first of all please observe that multiplication is possible because both the matrices A and A dash are squared matrices of the same order, so we can multiply. Now let us multiply, and to verify that, now take the product. Both the matrices being of the order 2 by 2, we can take the product. How do you take the product? Multiplying the elements of first row with first column. Cos alpha into cos alpha, you get cos square alpha, plus minus sin alpha into minus sin alpha will make it plus sin square alpha. Now continue multiplying the elements of first row with the second column. So you get cos alpha, sin alpha, and minus sin alpha, cos alpha. Now repeat the process with the second row. You get sin alpha, cos alpha, and minus cos alpha, sin alpha. Then multiplying with the second column, you get sin alpha into sin alpha, that is sin square alpha, and cos alpha into cos alpha plus cos square alpha. What do you find here? That cos square alpha plus sin square alpha is 1, sin alpha cos alpha cancelled with sin alpha cos alpha gives you 0, and here sin alpha cos alpha cancelled with cos alpha sin alpha gives you 0, and sin square alpha plus cos square alpha is 1. So here you find that the value of A dash into A for the given matrix is 1, 0, 0, 1, which is nothing but the identity matrix, and that's what we have to verify. Now the second part is exactly same, so you work out A dash and multiply A dash into A, and similarly you can prove for the second part that A dash into A is also I. Seventh sum, first part. Show that matrix A, you are given a matrix A of order 3 by 3, and we have to prove that it's symmetric. So what have you to show? You have to show that A dash is same as A. What is the definition of symmetric matrix? A matrix is said to be symmetric if its transpose is same as the given matrix. So what is A dash? How do you work out A dash? Write the elements of first row 1, minus 1, 5 in the first column. That of the second row minus 1, 2, 1 in the second column. And that of the third row 5, 1, 3 in the third row. And what do you find? Let me call it 1, the given matrix A, and A dash as 2. What do you observe from 1 and 2? The elements of the first row in both of them are 1, minus 1, 5. Second row minus 1, 2, 1. Third row 5, 1, 3. So I say from 1 and 2 we observe that A dash is same as A, so we can conclude the given matrix A is a symmetric matrix. Now in the second part we have to show that the given matrix A is a skew symmetric matrix. So what have you to show in a way? What is the definition of skew symmetric matrix? That A dash should be same as minus A. So let me first of all work out A dash. Let us call this given matrix A as 1. So how do you work out A dash? The transpose, take the elements of first row 0, 1, minus 1 in the first column, second row minus 1, 0, 1 in the second column, and elements of the third row 1, minus 1, 0 in the third column, and take minus sign common, that is divide throughout by minus, make a change of sign. You get 0, 1, minus 1, minus 1, 0, 1, and 1, minus 1, 0. Now do you find that this matrix, call it second. So from first and second, do you observe that A dash is same as negative, of course outside common, and you have 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0, exactly same as A. So we have verified that A dash equal to negative A, and hence I can conclude that A is a skew symmetric matrix. A is a skew symmetric matrix.